demonstrate. Okay, so we need to have a little bit of sample problem to the physical separation process called distillation. Okay, so distillation is a chemical separation process or physical or chemical separation process through its difference of boiling points. Okay, or shall we say the volatilities, okay, of different substances. Okay, so it's gonna be, we refer to continuous distillation, or shall we say simple distillation or continuous distillation. Okay, so now we have the problem here. Okay, finding the number of ideal stages for a feed of 70% vapor. Consider XF, mole fraction of the feed, XD, mole fraction of the distillate, XW, mole fraction of the bottom product. Okay, as mole fractions of more volatile component in the feed, distillate, and the bottom, something like that. Okay, so we have to consider the the theory for this before starting. We need to use the Mc Cabe Thiele Method. Okay, in determining the number of stages. Okay, in here, and then we need to follow the methods on how to do it. Okay, first you make a graph. Okay, I will do it. Okay, guys, you have to make a graph. Okay, and then it would be good if you will have the graphing paper, because the graphing paper you can buy in the market. There's a specific dimension, like the x-axis, the y-axis, okay, like that, and you don't have to draw such like this. But in this case, I have to draw, of course, because I don't have the graphing paper. Okay, right? So you have to draw a y-axis, okay, and the x-axis. Okay, guys. And then you have to be accurate also for this. Okay. Say like this until 17, right? Okay. Oh my goodness. Okay. So here also, okay, like this. Okay, and the first step, guys, is to make a diagonal line in the center. Okay, how can we do this? So let's just make a square to have a perfect diagonal, right? Oh my goodness. Huh? Kaloka? Sure. Uy, diba? Ganon. Oh. Oh, dito lang pala mali. Okay. Wait for a while, I have to draw the graph. Something like this. Okay, this is gonna be here. So this is the y-axis and the x-axis. Like this. Okay, your y-axis will be the vapor, and the x-axis will be your liquid, something like that, okay? So let's say V, or V4 na lang, isuwat na lang natin, should vapor. Here is square. The vapor and liquid, guys, has its own mole fraction, the same mole fraction. For example, if the liquid or the distillate has its own mole fraction XW or X bottom product, something like that. The vapor also has its own XW, same story. Okay, and then the vapor also has its XD, mole fraction of the distillate, and also the X also is XD, something like that. Okay, so both have their mole fraction as X. Okay, so now we need to construct a diagonal. Is the first method. Okay, like that. Okay, it should be perfect. Okay, length and width is equal, or else it will not be constructed during the making of the number of trays and counting the number of stages and trays or plates in the column distillation. Okay, distillation unit. Okay, something like the second step, guys, is to make an equilibrium line. Equilibrium line, we need to see the equilibrium point between the vapor and the liquid. Say for example, only hypothetical because we cannot really measure. Actually, you can make so many until the graph will be like this, a curve like this. Like this. You can make a curve, guys, if you, for example, if you have the X component here and the Y values, and then X here, the Y values, X here, the Y values, until you can connect like this. Since the problem is only general and hypothetical, it's not really specific here. Okay, it's not even mentioned the values of the, the mole fraction of the distillate, okay, the condensate, and the bottom liquid XW or the feed. Okay, so i-assume lang yun nato nga na-curve na siya. Kaya mo na siya permi curve. Okay, equilibrium line. So, sunod, we need to create our upper operating line. Okay, UOL. So how can we do the UOL, upper operating line, or simply the rectifying line, something like that. Okay, we need to connect the mole fraction of the distillate, okay, to the y-intercept. Okay, so let's remember the formula. Okay, so y is equals to r reflux over reflux plus 1 times x plus, okay, xd r plus 1. Okay, guys, this is the equation, right? And this is the slope, r over r plus 1, and this is the y-intercept, xd r plus 1. This y-intercept, you will make this into the graph. You will connect that to the xf, the feed. For example, if my xf, so I will label this as 0, for example, only 1, then 1, okay, let's say 0.5 here at the center. This is 0.5 also, something like that. And then 0.5 so 0.75 here. And then 0.75 here. 0.5 plus, so 0.5 divided by 2 is 0.25 here, 0.25 here. Let's see, guys, this one, let's say our xf is 0.75. Okay, so xf is 0.75. So this is the mole fraction of the feed, huh? This one. Then we need to draw a vertical line touching this diagonal line. Okay, like this. Actually, we need to have another color so that we can really distinguish another color. Okay, so I have here the green. So like that. So 0.75 like this. Tang, tang, tang. Tang, 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 tang. This is our XF. XF 0.75 touches this diagonal line, and we mark this as a dot or a point like this. So we have now a point here. Then we need to connect this to the y-intercept here, and we will use this formula, this one, xd over r plus 1. Okay, since for example, if our the problem solving, guys, is very hypothetical. There's no given of a reflux. Okay, reflux is equals to the L over D, the liquid that will return to the distillation unit over the condensate, something like that. Okay, so y-intercept, okay, intercept, or simply the B. The y-intercept is simply the B. Okay? From algebra, y is equals to mx plus b. So b is equals to the y-intercept, n is the slope. Okay, y-intercept is equals to xd r plus 1. Let's see, our reflux ratio r is 1, given our reflux, because there's no given in the problem, right? Okay, so let's say 1.5. Okay, so this is distillate. Sorry guys, this is distillate, huh? Because I remember that the distillate is always higher in the mole fraction compared to your what's the closest one? Your XF. Okay, so this is X distillate. And XF, for example, 0.5. Ato timan ang guess na ang feed usually sa center gud siya. Okay? Nasayop ko kaya akong XF to sa kilid, it should be in the center. Okay? 0.5. And let's see our bottom or XW, bottom product, distillate, is XF XW 0.25. Okay, so XD 0.75 divided by the reflux 1.5 plus 1, so pila siya 0.75 plus 1, 1.75, so 0.75 divided by 1.75. Y-intercept is equal to 4.3. Now, use this 0.43, plot that. Use this 4.43, plot that here and connect to the XD. Because you have now the Y-intercept. Okay? So, 0.43 somewhere along here. So, 0.5 plus 0.25 is equal to divided by 2. So, 0.5 divided by 2. 0.375 plus 0.85 divided by 2. So somewhere along here. So here, this is the 0.43. Okay? This is the 0.43, the y-intercept here. Connect that, okay, to the here, to the line, the diagonal line, because you have 0.43 in your y-intercept. Okay? One. Okay, like that. So it's gonna be like that when you connect that one. So this one, that, like this. So the y-intercept class will always connect to the distillate, mole fraction of the distillate. Okay, and now we need to find the feed line, which is the value of Q. So how can we solve this feed line? So we have the equation also y is equals to q minus 1 times x minus x to the feed. Ganon. Q minus 1. This is for the feed line or Q. Okay, so this is the B-intercept and this is also the slope. Okay, but in the theory, guys, this, for example, if you have a saturated mixture, one of which is saturated liquid and one of which is saturated vapor. Okay, now your Q will be the saturated liquid, not the saturated vapor. Okay, it's always mentioned in the problem, but sometimes it's not, but most of the times mentioned in the problem. Okay, because there is xf over q minus 1, and it's easy also to compute for y here. That's why normally this q will be computed, or will be given, sorry. Okay, like that. So for example, our saturated liquid will be 25% of the bottom product or the distillate. No, it's not condensate. Okay, like this. So let's say distillate, kay kuan man siya, liquid, saturated liquid, distillate, vapor. Okay, saturated is, for example, natay kuan 25% nga Q or feed line. So 25%, no, 25% is 0.25, ganun. Okay? Okay, 25%, so 0.25. So let's say our Q is, assuming na kaya ni siya ha, Q is equals to 25%. This one. If our Q is 25%, which is saturated liquid, so that is 0.25 our Q. Okay, ganan. Okay. Now guys, the XW, okay, will connect to the operating line, upper operating line. So after connection, the X distillate to the Y-intercept, this is now our connection here. We will connect also the QW here in the upper operating line, UOL. This one, upper operating line, or the rectifying line. So i-connect na yun mo ang XW. Okay? But you cannot sure where to connect unless you have the feed line here. So we need to compute, right? So feed line, so we have XF, again Y-intercept here, ha? Kung na Y-intercept here, nasa Y-intercept ang feed line. You get the point? If there is a Y-intercept of the upper operating line and the rectifying line, there's also Y-intercept or B for the feed line or Q line. So gamito natin siya, XF over Q minus 1. So naman tayo XF, so 0.5. So Q is 0.25 minus 1. So pila siya, 0.25 minus 1. 0.5 divided by 0.75. Negative 0.67. Okay, negative 0.67. Okay, that is negative, so it's a problem for the Y-intercept, right? Okay, it's a negative. So we have a Q 0.25 minus 1, and then our 0.5 here is the XF given. So we can obtain negative 0.67 B-intercept, and then it's look like impractical, something like that, right? So we need to go to the slope in here. Here, Q over Q minus 1. Okay, so Q equals to slope. Igano naman siya, slope M, okay, is equal to Q nga naata 0.25. So 0.25 minus 1. Oh, pila naman na siya. So 0.25 minus 1. So negative 0.75. Then 0.25 divided by 0.75 negative, right? Okay, 0.25 divided by 0.75. Kailangan siya. So, 0.333. Okay? Negative 0.333 ang slope. Negative m.33 ang atong slope. Now, in here, guys, when you connect the dot to the line, so what comes on your mind? Okay, you need to erect a horizontal line. When you erect the horizontal line, somewhere along in the printing line, you can create a right triangle, something like that, or a triangle. Okay, so yeah, we have the slope man siya. So, gamiton na ito mo ang algebra. Na, okay, get the point? So, slope, ganun siya. So, gamitan ni mo og tangent theta. Okay, naman siya kuan, base, nasa siya height. Okay, you got the point? Okay, so it's gonna be like that. So, tangent theta is equals to h over b, and then slope of is equal to, okay, arctangent siya, diba? So, tangent theta is equals to n, or the slope, right? Kaya ang slope mo man siya yung formula, tangent theta. Okay, that means the base over the height over the base. Okay, so arctangent of the slope n here. So, arctangent of negative 0.333, pila man siya. Muna yung angle. Kung ano yung angle, guys, here, sa horizontal, para makakuha ka o ma-erect mo ba, ma-connect mo sa XW. Get the point? So, 0.333 negative arctangent. So, arctangent negative 0.33. So, this is 18.41. Okay? So, 18.41. Ganon. You will project 18.41 here. Angle from the horizontal line. Connect mo siya direct. Straight mo ang XW until touching the UOL. Okay. Ganon. Okay. Para makakuha kang feed line. Okay. So, ang feed line is negative 0.333. So, i-connect mo ang XF. You get the point? Okay, like this. So, unsa to siya? 0.18. Something like that. So, somewhere along here. 18.41 ang angle. Mag-draw din kang angle ha, diri. Like this, here. Oh, here, okay? Not that. Here. I-connect na yun na mo. Okay, ang Q. You got the point? So, here, ganun siya. Connect mo, okay? You got the point? Kung siya 18, di ba? 18 degree. 18.41 degree. Yung mong banabanaon ang 18. Mga ganon. So here. Okay? So here, mga ganon. Gamayon na to. So, kanon siya 18.41 ang angle here. Dara, ano siya? Nag-draw kang angle here, ha? I-connect mo ang XF to the diagonal, the same as what you did in the, in the distillate. Okay? like that. And then guys, 18 degrees from this horizontal. So this is your Q. I-straight din mo ang Q. Ganun, i-connect ni mo reari. So, manan mong kuan values. So, manan mong Q. Kani siya, manan siya mong Q ha kani. Okay, so Q or feed line. Feed line. Okay, guys. Like that. You got the point? Okay. Now, after that, ang XW, i-correct na sa di mo sa Q, touching with the intersection of this one here. Okay? Here. There's an intersection, right? Okay, intersection from this Q line, and then the upper protein line is also intersecting, and then the common point connect that also is XW, gano'n siya. Okay, so muna na siyang may tabo. Okay? So gano'n. So, let's make this solid line, kaning broken line. Siya, and then we remove this. We no longer need this. Only the points we need this later for the counting of the, you know, the number of trays in a ratio and proportion, but later. Okay? What I mean, hindi siya mag-apin, nagkaihap-ihap sa kuan, sa tray. Okay? Like this. So, ganun siya. Muna siya metapo. Okay? So, ano na nato siya? I-connect. Okay? Okay, like this. Connect siya. Connect the, you know, the stripping line to the upper operating line and to the Q line. Wala siya. Okay, guys? Connect the upper operating line, the stripping line, and the Q line. Or the feed line. Ganun siya. Okay? Now, kung siya may tabo. Okay, now after connecting it, you will draw a tray. Okay, you will draw your tank. I-connect mo siya here, starting from the distillate horizontal and then vertical, just like a triangle, something like that. Okay. So, sugudin mo mga triangle there. So, okay, ganon. 1. Muna na siya ang tray ha. Oh, 1. And then two. Ano, sorry. Wala na siya. Sorry kayo guys ha. Okay, like this. Here. Bali imong triangle guys, ari din siya mo connect diri ari atong i-shade ha. Ganun 1. Mo na siya. Wala siya yung number of trays. 1, 2, 3. There are 3 numbers of trays needed ni siya. 1, 2, 3. Ganun. Okay, guys. But then, if you have a, you know, a partial reboiler, okay, for that, and then it should be 3 minus 1. 2 na siya. Okay, and the problem will state that one also. If there's a partial reboiler, partial condenser, subtract na mo siya. Okay, something like that. So, if there's a partial reboiler, subtract it by 1. Condenser 1, but having both, subtract it with 2. Something like that. Okay? Muna na siya. Okay, ang may tabo. Okay? So, we will connect this also here. The XW to here. Sa ganun. Okay? Ganon. I-connect mo siya ari. Draw a line. Okay, connect niyo mo siya ang XW guys here to the intersection sa operating line niya sa sa equilibrium line. Kan equilibrium line man siya. And then you will get the height here from this to here. Okay? Straight, connect also straight like that. Okay? And then make also horizontal here. So you have now a big triangle and a small triangle. And then you have to do ratio and proportion so that this will be added in your, in your counting of the trace. For example, 1, 2. Here, 1, 2. Actually, 3 man siya total. Pero 3, kinaman siya not perfect. We need to subtract this also. So, point something. So, okay, ratio and proportion. Let's say, ganan. So, i-count mo siya pilang values diri ari nga. Okay, graph man siya. So, for example, na siya point something. 0.7 over 0.8 o mana na siya imong value diri. So makakuha na kag triangle na mao ni siya gamay. Okay? Kay imo mang gitungkad diri ari. Okay? So makakuha na kag another nga gamay mga point something. Okay? Get the point. So 2 plus something naman siya ratio diri ari. Okay? Ratio diri sa taas ikan diri, ang ratio sa diri sa gamay diri ari o diri sa. Okay? Get the point? Muna siya ratio broke up. Okay? Dako nga triangle o gamay nga triangle. Ganon. Okay, nalang na triangle diri ari. Kare siya, kare diri. Okay? Kare nga height. This is the height ha. Dili siya, kare kay. Dili naman na siya triangle. Apin hindi mo siya sa triangle. Dili ra kotob. And then there ibo na siya i-ratio. Makakaw kag point something. I-add yun mo sa 2 ka raise, 2 point something ang raise. Ang trace o ang plates na dipangita sa distillation. Okay? Ganun lang siya. Diba? Because this is, ano man siya, hypothetical. Actually, nag-create tag 0.75 diri nun. Ang given niya, 0.70. Pwede sa siya 0.5. Okay? Kaya po man ni siya, hypothetical, 75%. Okay? Nakalimot man ko nga nari 70 diri ari. Okay? Yung mo to ni gamit ko po 75 nag-assume ko pero actually mora na siya. Okay? Gata po mo na gani siya drawing ra ka. Okay? So mo na siya pero bisag tuwa-tuwa makabaw naman ka kay imo man naman ko yung mga values i-connect ganon. Di ba kasi imong timan-an guys the mole fraction of the distillate will touch to the diagonal line. Okay? And then, it will also intersect to the y-intercept here. Ganon. And then, XW also will intersect to the feed line. Okay? Will intersect to your feed line. Also, here. Okay? And then, makakreate na kag something, then draw na yun sa draw na yun ang iyang number of trays or number of plates para makabaw ka how many plates and trays you will need in your distillation. Okay guys, if the more ng the reflux ratio no, so if the reflux ratio got given sa problem is very high, okay, so your number of trays, theoretical trays and plates will decrease. Okay, na kung gamay na imong reflux, okay, mudaggan ang imong theoretical plates inikat drawing nimo. At the point, if the reflux is very low or very less, there's a lot of theoretical trays and plates. Okay, not that actual the actual plates will be computed based on the overall efficiency. Okay, overall efficiency of the distillation unit will be percent equal to the theoretical number of plates over the actual number of plates. Then usually, we don't know the actual plates, okay? And we have the theoretical plates. That's why we have the problem solving, right? Or else, we don't have the problem solving anymore. Kinakabaw na bang katanan sa plates? You get the point? Nakikinahanglan sa imong distillation. Could either be wala gid siya plates Permi ang ipangitaan niya. Or pwede sa dihatag ang plates, di baliho niya. It will ask for the reflux like this. Okay, it depends on the situation, but most of the times really, number of stages will be asked. Okay, and like that. Okay, so that's the relationship between the reflux and the theoretical number of plates, something like that. Then if you know also the relationship between the theoretical plates and the plates, and do algebra. Okay, so like this. Actual plates times the overall percentage is equals to the theoretical plates. Then compute for the actual plates is equals to the theoretical plates over the the percentage efficiency. Then directly proportional siya. So meaning to say mo increase pa yung actual plates. Then ganon. Atong i-equal na algebra. Okay. Puro mo gina siya Permi oy. Kaloka. Okay. Overall efficiency of the distillation unit and may gitawagan na niya no. So percentage overall efficiency is equal to theoretical plates over the actual plates, di ba kani siya? So i-n na to ang percentage, so n is equals to theoretical plates or trace over AP. Ang trace plates na siya or stages, the same thing. Stages, plate, trace, it's just the same in meaning, okay, in distillation. And then you have to compute for the AP, so AP times N is equals to TP, and then AP divided by to the TP is equals to N. Ganon siya. So if you increase the actual plates, of course, increase na yung theoretical plates. Kaya mauro magyapon na siya yung kinanglan. Right? That's why nga mag-compute ka ang theoretical plates para you should know how many theoretical plates you will put. Okay, meaning to say, they are directly related with each other. Get the point? No need siya talaga i-stress. Common sense man siya. So, ganun-ganun siya. Okay? Get the point? But I think the theoretical plates is more on the maximum. I think in my own analysis. Meaning to say, it's a maximum that is needed. And then the actual plates will be taas gid siya ang imong kung gamay imong efficiency. Di ba? Kung gamay imong efficiency, daghan kay kinahanglan nga actual plates. Pero kung efficient na kayo mong distillation column, you have only to need small number of actual plates. Parang tama. Yes, okay, because the more it is efficient, the more we no longer need trace ba yan? Okay. What's the use for another trace kung efficient na siya sa unang plates pa lang? Diba? Nagasto-gasto lang kasi yung number of plates. Diba? Mabitang design ka of plates, and then if you want to design a plates required, then you will go for the less number of plates rather than so many plates or trays in the distillation column so that you can save money or cost. So this you will increase your efficiency of your distillation unit so that you can need only fewer actual plates needed in your distillation process. Okay? Something like that. So, wala siya. Loka. Diba? Okay, this is hypothetical magod siya. Okay, and then, the feed, more fractions of volatile component. Okay, ano siya. And now guys, atong i-show ang overall material balance ha. Ani. Okay. Usually naman si question na yun ani. Okay. What is the value of, what is the amount of feed needed to produce a product, a condensate of 100 mol. Okay. So, ganoon siya. Then you have the equations man siya. So, we have the energy balance and the overall material balance. The overall material balance, guys, kaya siya. Okay? So, kung naka distillation column na mo ni siya. Okay? So, imong feed, ari mo sulod, di ba? So, feed, yung imong distillate mo, gawas man dito ba sa condenser, di ba? Okay, mo nimong distillate. Ang imong bottom, imong condensate mo, gawas po ari. Mo ni siya. So, assuming there will be no fraction loss or there will be no waste of energy, and assuming theoretically that you have a constant equimolar flow and you have also a constant heat loss, meaning negligible, and the heat also of mixing is constant or negligible, and also your heat of vaporization is negligible. These are the conditions for the Mc Cabe Thiele method. So if that is not the case, then you will not use this Mc Cabe Thiele method. You get the point? Again, in using this Mc Cabe Thiele method in determining the number of stages and trays in your distillation column, like that, okay, the conditions or criteria must be met. So number one, the heat of vaporization that will goes up or go down in your inside the distillation column will be negligible or constant. Heat of vaporization. Remember, the heat of vaporization of water is equal to 530 calorie per gram. Okay, something like that, 2,260 kilojoules per kilogram. Okay, and 40.8 kilojoules per mole. So those values I spoke to you now will be constant and negligible, will not contribute into your computation. As you can see, there's no constant values in that equation in the distillation because negligible man yun siya. Okay? Or else it can be used in the Q over Q minus 1 in the feed line. Okay? But never. Okay? Because vaporized ba ang kuan feed? Ang liquid vaporized, di ba? So dapat mo account na ta siya. Wala siya giapil-apil. So maybe ito sa negligible to siya ang heat of vaporization. Number two, the heat of mixing, because there's heat involved here. You heat the liquid, the feed. Okay? Because usually in distillation, your feed will be liquid. Usually lang. Pero meron sa siya solid, pero imo yung i-heat yun imo ang liquid in most cases. Pwede mo sa good solid o liquid. Mara magyapon, hit ra magyapon yung mga liquid ng solid. Okay? Something like that. So, wala siya ang iyang heat of mixing, negligible yapon siya. Or else, gamit ang Q is equals to, MCP dt, ganun. Sa thermodynamics, so wala man siya. So, meaning, negligible good siya ang heat of mixing. And of course, the heat loss also is zero. Wala good siya. Ganun man, kay namang butay reflux. Ang reflux mo, balik man siya dito sa distillation column. So, gi-assume din siya na wala siya losses. Mubalik lagi po siya dito sa distillation column, mahimod po na siya o condensate. Ang liquid nga mo, padung sa ubos. Okay? So, mabalik-balik na siya, then musaka na po, mahimod na po siya distillate ang katong gi-add mo nga reflux. Cycle raman yun siya, pero ang liquid mo, vapor man po siya inikahit. Tuyok-tuyok na siya ba? Okay? So, sawon na yun dito sa reboiler. You get the point? Ang liquid. Okay, inigasaw dito sa reboiler, mahit na po siya. Magpulos na po siya condensate. Balik siya dito. Ano siya, okay? Ganon. Kanoka. Okay, kaya ang vapor light man siya. Kung saka na po siya balik sa distillation column. Ano na good? Okay? Kung imo gina siyang subtone, makabaw man ka. Okay? You get the point? Ganun siya. Okay? So, overall material balance. Okay? So, F is equals to D plus W. Ganon. Feed is equals to distillate, which is the overhead product, plus W, which is your condensate or your bottom product. Okay? We should identify it carefully. What is a condensate? Okay, the condensate is really the bottom product that will go at the bottom part, meaning large molecules, larger molecular weight, bigger density, and bigger boiling points. Kailangan siya sa ubos. Okay? You get the point? Now, kung nasa sa ubos, guys, ano man yung concentration? Ubos or taas? Hala. Kung pagkuhan siya sa ubos, nasa sa ubos. Kung sa may metabos imong concentration sa bottom, if sa liquid, kung nasa siya sa ubos, wala siya sa taas. Unsa man, taas or ubos. Di mo din hinumduman ang mass transfer. Okay, if we have also in a first law of thermodynamics ba to siya, that the transfer of heat starts from a high temperature to lower temperature, and the motion or the velocity also of the fluid starting from a very high velocity to lower velocity. Mausab ni siya ang concentration. Permanente maugid siya. Wa mausab sa Fury. From high concentration to lower concentration po din siya. So meaning to say, from lower concentration, okay, inisaka man siya ang vapor, yung liquid naman siya sa ubo, so lower ang concentration sa liquid. Okay, taas ang concentration sa vapor. Okay, di ba nakakuha ka? Muman na siya ng tabo. Kaya ang liquid, di pa doon mo siya sa ubos. Okay? Yung ikasaka niya, taas siyang concentration. Mabito na, tanawa ra guys, the XW or the bottom mole fraction is always less compared to the distillate. Kaya distillate, tuwa mo na sa taas. Obserbahin yun per sa problem solving. The distillate mole fraction, yung tanawon ko, di mo rin kumpara, dili na ka mo solve ba? Imo tanawon ang iyang theory or principle. May bawaan sa nani mo. Pero may i-given sa problem, gamay yun ang iyang both from to say the concentration of this liquid is always lower than the concentration of the vapor, in which ang vapor nasa taas, ang liquid nasa ubos. Another side also, another also in electrochemistry also. You get the point? The electrons also will flow from higher voltage to lower voltage. Usad siya. Okay, you got the point? Yeah, from high current to lower current sad siya. Pero mao gina siya per dili mausab ha. Okay, from higher to lower, chupa-chuchu. So unsa na siya nga quantity? Could it be velocity? Could it be current? Could it be a temperature? Could it be an energy? From higher to lower gid siya. Okay? Get the point? Ganun siya. So, para makuha na to ang principle ba, hindi ka, kuha mo, may bawaan magod mo kay, for example, ipagita nimo ang mole fraction of the bottom, compute mo niya, taas ang imong concentration sa bottom niya, di ba, niya, gamay imong mole fraction sa distillate. So, sayo po imong solution. Okay, nagaguhago ra ka. So, dapat makamao ka sa theory. You got the point? Muna siya natabo. And then ang feed, average ra siya, kaya naman siya sa tunga. Okay, sa distillation guys, ang feed, i-introduce ko siya sa tunga-tunga, dili sa kinaubsan. Okay? Mo gina ang design niya, nasa tunga. Buk lang mo na siya. Okay, so F is equal to, ang energy balance ni mo guys, muna ni siya, F times XF, D times XD, plus W times XW. Equation 1, equation 2. Ganon. So, magsubsob ka ani niya na yung mga, okay, mga given or fraction 3. So, makuha na ni mo kay mag-equation man ka, mag-linear equation. Murag algebra ba? Equation 1, equation 2, equation 3 niya. Substitute din mo sa equation 1, equation 2. So, simplify man ikadugayan ang mga substitute ni mo, makakuha ra dayon ka. Okay. Nasa sa nga, ang feed ray given, wala ang distillate ug ang kuan, condensate. So ay kahadlok right as that as an equation 1. Okay, total lang sa energy balance here. Okay, ya ini ka-substitute mo sa mga mole fraction, makakuha ka, i-substitute nimo dito ang F. Yan ang sa kay F diri. Kuan nimo magpariha man ang iyang units, so masolve na nimo ang iyang D and W ganun. Usually ang kaning mga mole fractions given man gyud siya. Mga concentrations ba? Okay? Now, or else, kung dili kay wala gigiven pa kayo ang mga mole fractions, ang gigiven pa kayo ang diri, ang distillates, ang weight, ganun siya. Masabtan naman siya, di ba? Good point? And then use also the value of Y in the rectification line or operating operator, and the value of Y in the feed line. Duha ni siya ka Y guys sa ang distillation. Okay? So, nagbase niya siya sa algebra nga Y is equals to mx plus b. Okay nga slope ba? Okay? Now, there is a distillation duha. Rectification line or upper operating ay kalibog. Mao gina ang upper operating line or rectification line, mao ra siya, pareho ra na siya. Okay? And then, ang imong bottom operating line, mo to katong mo connect dito sa Q, sa feed line katong sa XW. Hindi mo siya timan-an. Connect mo sa to siya dito sa kuan, distillate. So, na siya point man, i-connect rin mo siya. So, di siya mulubog, kaya makunik man siya. Okay? Like that. And then, ang imong timanan yun, ang imong bottom, XW, mo connect siya sa feed line. Wala. Mo connect siya sa feed line o sa upper operating line. So, kung na-connect na siya, guys, mo na imong bottom operating line. Okay, bottom man siya ang isgutan. Klaro ba bottom? So, bottom operating line, di ba? So, upper operating line. So, nasa taas, the terms itself speaks for the terminology. Also, but the problem is sometimes they will never use that upper operating line, bottom operating. They will use the another terms na probably sa mga examinees or sa mga students. So, actually, the another term for BOL is the stripping line. Okay, stripping line or the vaporization line. So, sometimes mo na siya ihatag na term sa problem. So, stripping line. And then the rectification line, mo na siya ang upper operating line. Ay mo kalibog kayo, change lang term. Okay? And then your feed line, ay mo tunga ba ang feed? Mo na siya ang flashing zone. Flashing zone line. So, muna ang mga technical terms na kung dili gihatag atong mga common na term nga gi-discuss atong maestro sa college, mo na ihatag sa problem. Okay? Dapat makabaw ka unsay mga another term. Okay. Usay ra ba magsige gamit atong instructor o atong sa college, mo argue permi ang gamiton nga term. Nya, not knowing na another term. Nya ni kapasok dito sa actual examination, mag-expect ka asa naman itong operating line? Naman siya pareha og term. So, mauna to. Muna siya kasagaran sa muhagbong ang uban kay wa may sila'y terms nga lain nga nasabtan. Katulad yung permi ba? Get the point? Daghan ba yung siyang term? Okay, imo siya tukion. Nga ba? Okay? Like that, bottom product. Kibaw ka ang bottom product, mo man ang condensate. Okay? Ni ka-discussion sa maestra, hindi man siya mo gamit og condensate. Mo ana naman siya, the bottom product, na siya ang liquid niya. Hindi ka po niya sa problem. Naon din niya, how much condensate will observe? Naanad ka sa, what is the bottom product or liquid content or, vapor content? Gano'n, wala na. Okay, dapat makamao ka nga. Kanang condensate, mauna siya ang bottom product, mausad na siya ang vapor product. So that sa question sa problem, kaning tulong nga terms, either three ani nila mo ibutang sa problem. Okay? And then sa taas sa distillate, nasa siya term, distillate, liquid content, and the overheat product. Sometimes distillate ang ipangita. So what is the distillate? Ganon. And then sometimes ilisdan na po siyang bottom product. Nimora na ang distillate. Sometimes also they will ask what is the liquid, liquid content that will be produced in this distillation unit. So liquid content man siya. So distillate. Okay, since condensation, we condense the vapor to produce liquid by cooling. Mabitaw natin condenser sa taas. Okay? In that technical terms alone, makasabot ra ka kasi di na siya mao ang term ginagamit na sa question yung ma-encounter in the future. Especially sa board examination. Okay? Yung anak din siya, lainon. Okay? Nakakaloka. Bitkon ra ka ba? Bitikon ka sa mga terms. Ganun siya. Ganun siya ka-traidor. Okay? Mga reversible reaction, sometimes gamitan din the irreversible reaction of enthalpy kibaw ka nga irreversible non-spontaneous na siya the positive value din ang G, ang internal energy niya bigo din spontaneous reaction ganon dili din state ang kuan kibaw ka nga spontaneous negative kana siya kuan na siya reversible. Marok lagi kayo, i-apply din ang reversible na ang kanang reversible nga term, apply na rin sa chemistry, dili dito sa mga thermodynamics, sa thermodynamics. But then, ibalik ra po din na nga term. Anyways, ang students, dili siya familiar ba? Kaya wala naman nga gina-practice nga term. Nakakuha mo? Gina-practice ang term usually, ginagamit sa first year college pa ka, sa chemistry. Diba? Ano, not knowing pala, ikaabot din mo dito sa higher subjects, pwede na sa to siya i-inis nga term dito. Now, karon ang mga maestra o mga instructor, magsige gamit ana nga term. Ang students, mag-uban siya, okay, mag-uban siya nga term, in which naabot ra ana nga year, in which pareho ra din na siya katong first year pa ka. Nakakuha ka, mo na siya. Okay mo na, kasagaran mo fail, kay dili man nila i-remember na mao din na pareho ra siya. Nakakuha? Okay, ganun siya. Nakakaloka. First, anong melting point? Good. Okay, ang another term sa melting point, kay fusion point man sad. What if, ano sa ang problem? What is the fusion point of ice? Mga nga, kayo makakabang sa fusion. Pareho naman nag-melting. Kinaanad diya kasi melting point gamiton sa libro, sa mga libro, sa mga handbook. Dili biya kasagaran gamiton ang fusion diya. Pareho ra biya ang fusion ug ang melting. When you do the fusion, it will melt baya. Okay, you undergo, you apply temperature. Okay, may nga for example, nasa ka ng line product. For example, distillation. Mo masad na ang deposition. Okay? Nakakuha ka, change from gas to solid. Lisod jud kay i-change ang gas to solid. Okay, but there's a process for that. Okay, mo na siya ang deposition process. Okay, physical process. Now, kanang wa man kakasabot kay ano, kay wa man agibalik kasagaran sa mga instructor nato, kay sige man tagdilog sublimation. Okay? Wa man kay tanidil aning balik, deposition or desublimation. Okay, ang term nga D, removal ra man na siya, god man nagipuno sa D. Okay? Sana mga degeneration, okay, mga na-D sa unahan. Okay, demobilization, okay, dehydration, gi-remove ang water mo ng dehydration. Okay? Nga siya. Deoxy. Okay, deoxy. Remove ba ng oxygen? Deoxyribonucleic acid. Okay, which is the DNA. Gabit siya sa kuan, genetic information sa, biochemistry. Diba, ano sa siya ang meaning? Deoxyribonucleic acid. Meaning ang oxy diha ang oxygen. So, gi-eliminate diha ang oxygen mo ng deoxy. Okay, basta ang word D, removal yun na siya, guys. And ika-apply niya sa term, mo din subtone. Okay? Nakuha mo na siya. Okay? Alak sa chemicals, daghang kasi nga ng process nga dehydrogenation. So, gi-remove po ang hydrogen. So, masabtan na yun mo, hindi ka na reaction kay ang gi-remove ang hydrogen man. Itungod sa word nga D. Okay? Sometimes sa term siya mag-aog. Okay, dili siya sa kanang daghang kang gisag-o nga mga kuan. Yeah, daghang lagi kay kag gisag-o nyo, makakabawas siya ang say limitation, di ba? Okay, thank you so much for watching this live streaming. And then if you like this video, you can comment down below in the comment section. Ako na lang dito yung gibisaya, okay, para di pasapin akong dila. Okay, in fairness. Okay? Yung mag-isod sa kong explain sa parts. Okay? Ako na lang yung gibisaya para maklaro. Okay, guys? So, to others na dili makasagot, pasensyahan na lang yun na. Okay? But what I mean really is that we have a lot of terminologies, technical terms in science, then you have to be extra careful to memorize other terms that have the same meaning, because in problem solving, it will be exchanged somewhere along in the phrasing of the paragraph. Then you will get lost because you are used to, or you are commonly used those terms in which you are practicing when you are still in your first year, second year, like that, and then when you go to the higher, different, something like that, and you need to know that. Okay? For example, solubility and concentration is just the same in meaning. Okay, but we never use the solubility term in the physical chemistry and in the thermodynamics. We always use concentration, or directly using the unit. Okay, the molar, the molal, or the equivalence per solute. the equivalent per solute that what we call this one, the normality or the normal. The equivalent weight of the solute over liter of the solution, that is the normality, right? Then our unit for that is the normal, capital N. Okay, and then the capital N normal will be equal to the replaceable hydrogen, di ba, kung acid siya. Then replaceable hydroxide kung base siya. I-multiply mo siya sa iyang molar. Muna iyang normal. Di ba, stock knowledge? For example, tagaan ka o ka ng molarity na concentration. Okay. 0.5 molarity, for example, sulfuric acid. And then, ay glabla imong ulo kung it will ask for normality. Nakibaw man ka ang replaceable H sa H2SO4 nga mukuan siya, mo-neutralize, 2 man siya, H2SO4, diba? So, makakuha siyang tugikan sa sulfate. So, muna imo siyang i-times of 2 ang molarity. So, 2 times the molar of this sulfuric acid will be your normality. Not necessarily computing pa itong mga equivalent solute over the molecular. Okay, madugay lang ka. Okay, so ang theory na lang. So normality is equals to the replaceable H times molarity molar in terms of acidic solution, or normality of the base is equals to the replaceable OH ion in a correlation, okay, times the molar concentration for that. So ayun na kung atong normality nga formula. That is kung given dyan ang molar concentrations. Kung dito siya ihatag, so buba ka sa iyang original equation nga katong equivalent weight of solute over liter of solution sa normality case. Lahi man ang normality, or lisod-lisod siya gamay, ikumpara mo sa molality o sa molarity. So, mo ni siya ang mga solubility or mga concentration. Okay? So, kini siya magamit per ni sa higher subjects, sa physical chemistry, sa thermodynamics, sa unit operations, o sa reaction kinetics. Kay dealing concentration yun ang reaction kinetics really. Mujud siya. Moles per liter kasagaran. Okay? Ganon. Yeah. Butangan na yung capital N yun ang normality ha. Ang molar sa capital N. Ang molality na lahi guys, small letter M siya. Kasi man, dili na siya i-express sa problem solving. Butangan rin siya small letter N, capital N, capital E niya. What akabaw sa inyo, mo na siya gimeaning. Okay? But other problems also will specify really, for example, molal. 0.25 molal of something like this. Okay? But others never specify also just small letter N, molality na siya. Or molar na siya. Okay? Small letter capital N, molality na siya. Ganon. Okay? So, muna siya nagtabo. Okay? So, kung gamitan pong molar, guys, imo siya na siya hinumduman nga moles per liter na gina siya. Okay? Muna siya definition. Sa harap, dili ba na mo siya i-express ba ya sa thermodynamics sa physics. Butangan dyan og moles per liter, ini ka-solve dito sa thermodynamics sa physics. Dili siya molar. Okay? Okay? So, muna siya yung mga similarities or mga commonalities or mga, ano na siya, tawagan na niya, hindi siya distinction ng pareho ba? Identical. Okay, muna siya. Okay guys, thank you so much. Good night everybody. Bye-bye. See you later. Ganon. Daoy.